start or me? Well, I guess I'm starting. Hello, everyone. Let's go into our intro slide. So my name is Hailey. I'm a DevOps engineer at Newy, and we have...
I'm Shilpa. I'm a senior software engineer.
And I'm Jemimah, Irvin. I'm a UX designer.
And today we're talking Agile Chatbots. Specifically, we're talking about how we took an idea, a business problem, and took it from a small team of, a small cross-functional team of different people, different parts of the business, took it through to continuous deployments every single day, all the way to production, and being able to iterate really quickly on a problem space that we don't really know much about. So we were able to take the feedback from running in production and go live with it. You want to go?
Yeah, so why a chatbot? Well, we'd had live chat available for some years, and that was manned by agents from the call center who were really familiar and experienced with talking to our customers about the Australian health insurance products. And we were reviewing the data and the conversations, and we saw a lot of opportunities to improve efficiency and the experience for the customers. I can't read the notes then. So one significant opportunity that we saw was to reduce the really frustrating conversations that some of our international customers were having. They would get onto live chat, they'd explain their problem, the agents would help them, and then towards the end of that conversation, after many minutes, the agent would discover that they weren't an Australian resident and they actually couldn't help them and would direct them to the call center for the international customers. So not only was it like minutes tying up their agents, it was also a really bad experience for the customer. So that was one opportunity, and it accounted for about 7.5% of the live chats, but the time spent as well was significant. Another opportunity was self-service. We had customers on live chat asking them to help with changing an address or making a claim, and these are things that they could all do online, but maybe weren't aware of it. We had situations where I think 22% of chats were about sales, and sometimes the sales chats didn't get directed to agents with sales experience, so there was an opportunity there. We also had about 35% of chats were about hospital and claims, and even though they're sort of similar, they're not the same thing, and sometimes these would get misrouted to the wrong agents. On top of that, the reporting was really rudimentary, it was manual and labor intensive, so there was huge opportunities there. So to make this chatbot something real and not just an idea, we spun up a tiger team, a cross-functional team with all of the usual suspects, engineers, business stakeholders, some UX, and along with that, we grabbed someone from the call center with chat experience so she could help us actually have these conversations through a chatbot with customers. And she was invaluable. She got training in Git, she monitored conversations, worked out what was missing, and helped build those utterances up. Something else that she was really invaluable was being a champion for the chatbot in the call center. When people started to get a little nervous, it was going to take their jobs. And so after some time and a bit of testing, we had this proof of concept, a working proof of concept, and we called it Nibby. Nibby is our chatbot. And we thought, okay, what next? So it became an MVP, and we sent it out live to start talking to our customers. And to start with Nibby, you would have, if you had a conversation, you would have had like one of three outcomes. If you're an international customer, hopefully you'd get a message saying, here's a phone number you need to call. If you had a self-service inquiry, Nibby would give you a link and tell you how you could go about doing it yourself. And for everything else, you'd be redirected to a live agent, and Nibby would hand you over. And we were measuring success on if Nibby understood and directed you to the right place. And at the start, we had about a 25% success rate. So that was, room for improvement. For the record, we're now at about 75% success rate. So we did make good on that. So with that 25% success rate in the start, that means that there was about 75% of people that were having a frustrating experience, both customers and agents. And so maybe you might be asking, like, why? Why did you just go out so quick and so kind of shoddy at 25%? Why didn't you do more research, talk to more people, interview more customers, test it more? Well, reality is, getting it out quickly was the best way we could learn. We learned from real customers, working out what actually they're saying and what they expect from a chatbot and how they use it. Just go back to my notes. So we're going live with our MVP. We were able to really rapidly learn and build and iterate and change it as we went. So I'm going to show you some experiences that we learned really quickly were frustrating and we were able to rapidly iterate on. So One thing that we had never seen really with live agents was people asking to cancel their health insurance. It just didn't come up. When we had Nibby, it came up a hell of a lot. I think in retrospect, of course, you don't want to talk to an agent about cancelling, but if there's a robot there, absolutely. So that was one of the first new intents that we put into the bot was cancellation. Nibby was built with some experience of how agents interact with customers, but what we discovered was that when they're talking to a bot, it got really confusing, being polite. So even though we were thinking, oh, yeah, we start with, well, I'm Nibby, what's your name? Customers just jumped straight into what they wanted, and this sort of thing happened. So that got changed. And then when Nibby started to do a good job and people said thank you, Nibby didn't know what to do with that. So we began to iterate and get our conversation design to be something a bit more fine-tuned. So this 75% success rate that we're now having, we're getting a lot more people to the right place, and we're looking at new ways to keep building out opportunities in the chatbot. But we'd also like to smooth off some of those rough edges with Nibby because there's really a lot of opportunities there. Something we've observed is that allowing free text can create some friction for users. So I'm going to give you an example of that using a non-health insurance. Let's imagine I've got a chatbot that can help you order some fast food so that it gets the timing right. So as soon as you leave the house and go to the store, it's ready, hot and fresh, and you don't have to waste any time. So there's a chatbot that'll do that for you, and right now you feel like a Happy Meal. And then this happens. Now, assumably, someone at some point is going to look at those chat logs and be like, well, we need to fix that, and we're going to put in colloquialisms, we're going to put in typos, we're going to make it a lot more forgiving. But we're starting to think about, well, if there's only limited answers and we know what those answers are, why don't we help customers so they don't have to learn the language of the bot, but we can actually just be like, these are the options you've got. So what we're looking at now is something like this. We know maybe that the bot only does 2 or 3 things, so let's just make that really obvious for customers so they don't type in Subway and the bot is like, well, I don't know what that is. So for things like yes or no answers, or if you've got 3 to 5 select options, this creates a better experience for the user. It reduces some of that friction. The flip side is you're going to lose some opportunities to learn about what language customers are using to ask questions, but this does provide that confidence in a bot that it's actually there to do something useful for you and be the fast food bot rather than the frustrating fast food bot. Okay, we've also started to look at research in the space of conversation design because people have been studying conversations in linguistics for far longer than we've been building Nibby. So looking at pragmatics and what people expect from conversations and trying to build that into how we create new intents and new conversation flow. This is all really new to me, and so what we have is a really rudimentary set of guidelines, and being agile, I'm just kind of like, let's try it out and test it and build it out as we go, and just keep referring back to some research that's already existing in the space of linguistics. So that's all I have to say on conversation design, and I'm going to hand it over to Hailey.
I hope it's okay. Is the sound coming through? Cool, excellent. Right. So now that you sort of understand some of the business drivers, some of the context behind why Nibby, I thought it'd be useful to actually go in and look at how we've done this. So we've done a lot of cool things to enable this continuous delivery and constantly pushing to production. This is our solution architecture. I will be going into this in more detail over the next few slides, but the thing to notice initially is that it's entirely serverless. If you've never worked with serverless before, and I don't mean just Lambdas, I mean like serverless applications in general, there are a few main benefits you get. First of all, it's cost. Nibby costs us less than $10 a month to run in production. That is some very, very low fees. That also means we can spin up as many instances as we want in test without worrying. Serverless makes it really easy to spin up these unique isolated stacks where different team members can start working on feature X and feature Y and don't impact anything else. It's very fast to deploy. It takes minutes to get the whole thing out. And fundamentally, I think the biggest benefit of serverless is that you can focus on your business logic. You can focus on what's actually bringing value instead of worrying about, oh, do I need to patch these servers? Do I need to do vulnerability management? All those exciting things. So the first step, if you were to go to the Contact Us page, and you can, but please don't actually go through to a live agent. If you were to go there, you would be loading a static React-based site out of S3. And from there, we would actually want you to start talking to Nibby. Problem is, Nibby is hosted in AWS, and nobody has access to our AWS account unless you have permission, if you log in, to be particular. So we had this problem. We obviously don't want customers to just log in. We don't want to have that friction. We want people to just be able to start typing, like, hello, I would like some help with whatever. So this is where a service called Amazon Cognito comes in. So Cognito is a serverless authentication and authorization platform. There are two main concepts in Cognito. There's the user directory, which is kind of a list of all the users and their sign-ins and things like that. We don't really use that with Nibby. What we do use, though, is the second concept, which is identity pools. Identity pools roughly assign permission sets. You can think of it as being like a member of a certain AD group, or maybe having some OAuth scopes associated with your user. So the thing with identity pools, though, that's really useful for us is you can configure them to have unauthenticated, you can configure them to allow unauthenticated access. So what that means is, under the hood, silent to the user, we make a request to Cognito and we go, hi, please get some credentials. So we get some temporary credentials. These credentials are very, very, very limited in scope. They actually only allow the user access to one Lambda, and this is our chatbot Lambda. You see, I think I have a button, whatever, I'm not gonna figure that one out. So the chatbot Lambda is effectively a proxy into the environment. All communication into AWS and out of AWS from the chatbot goes through this chatbot Lambda. I think that's my hair. And the nice thing about that is, obviously, we've reduced the security scope, but we also have a nice hook into log everything. We can actually get a log of every single part of the conversation, which means we can later push that off to a call center agent, or we can maybe do some sentiment analysis or other sorts of analysis on it. If you haven't heard of Lambda, I'll be brief because I figure a lot of people have. It's a functions as a service platform. This allows you to not run servers. You just write the business logic and you go, here you go, Amazon, please run this for me. It's event-driven. You only run it as required, which also means you only pay for what you actually use. The downside is, of course, there's a limited environment. There are only a handful of languages available. Python, Node.js, I don't remember the rest. It's the ones that I mostly use. And there is a maximum now 15 minutes as of a couple of weeks ago duration. But if you can deal with those constraints, you actually get a lot of flexibility, a lot of scalability, and of course the ability to outsource your operational maintenance to Amazon. And they're really good at that. They have hundreds of people to do that. So now that we've got the communication flowing into our AWS infrastructure, we pass off to the service called Amazon Lex. So Amazon has a bunch of services that I would describe as AI ML in a box. It's kind of like an API, you just pass it some data, you pass it a request, and boom, you get some smarts out of it. This is awesome because I do not understand AI ML at all, and don't really have the time to figure that out, and we didn't either when we were starting this project. So we used Amazon Lex. Amazon Lex, you can't really see it very well up there, but is a chatbot framework service, I suppose you could say, that's created by Amazon. Essentially, it relies on the deep learning and machine learning and natural language parsing algorithms that Amazon already developed for things like Alexa, and you can hook into it, not worry too much about how it works, and just simply actually define the business logic that provides some value. So, as a developer, you define these things called intents. An intent is basically analogous to a use case or a user flow. You go, okay, my user wants to get some information about health cover or McDonald's or something. Within an intent, there's kind of subcategories. There are utterances, which are sort of like rough keywords that Lex will be looking for to determine which intent it's trying to match to. There are slots, which are basically empty variables that Lex knows it needs this information in order to process the request. For example, it might be, what is the customer's name? There are prompts. These are basically just questions that Lex is going to ask to try and elicit the variable, the values for those slots. And finally, there's fulfillment. This is basically what Lex does after it figures out everything it needs to know. This, for us, is a whole bunch of lambdas. We have somewhere around the lines of 20 intents, I believe. Shilpa's going to talk a little bit more about that. Which means that these fulfillment lambdas do a whole bunch of different things. The nice thing is, though, is that you can get quite granular about it. So as you can see, some of our fulfillment lambdas push off to a live agent. They might return some information from a knowledge base or a deep link into online services or something like that, or they might do an actual transaction with another microservice within our infrastructure. So The cool thing about this, though, is that because Nibby has already figured out what the intent is, it can actually more granularly associate the fulfillments with whatever the user's intent was. So we can make sure that Nibby sends a user with sales questions to a sales-trained live agent. But you may have noticed, I mean, I've been banging on about serverless infrastructure and how awesome it is that you don't really need to run servers, but suddenly I've got like 30+ components to manage, and that's, we've sort of traded one problem for another. So the way that we deal with having so many small components is we write it in code. Hopefully you can appreciate, if you're here today, why we wouldn't just want to do all of that in the console and then somehow deploy that to production by copy-pasting. That would be a terrible idea. So we define everything in code, and specifically we use CloudFormation. If you're not familiar with AWS, it's basically a language/tool set that allows you to define AWS resources in YAML or JSON if you're really like not having comments and things like that. And we also use a tool called the Serverless Application Model, or SAM, which is basically a library that sits over the top of CloudFormation to make it easier to define things like lambdas. I won't go into too much detail about this because you could probably talk for 30 minutes about CloudFormation itself, but needless to say, this enables us to deploy our isolated stacks. It enables us to make sure that what we're doing in test is actually going to make its way all the way to production. So we use, CI/CD tools. We actually start delineating based on branches. So if something's in master, it's going to go to our test environment, and then once it passes a few tests, it's going to go all the way to production. If it's not master, though, we can actually take that CloudFormation template, pass in the branch name, and boom, we have completely isolated infrastructure. Then teams can work on whatever feature is there. They can, test it as they will. All that sort of cool stuff. One problem with CloudFormation, though, is that it's always behind the 8 ball. The CloudFormation team is always trying to play catch-up with the new releases across the other teams in AWS. They do, two pizza teams kind of thing. So Lex is not supported in CloudFormation at all. So how we've approached this is we used CloudFormation's ability to define custom resources. Custom resources is effectively two parts. There's a way you define in the YAML looking like any other resource in your CloudFormation template, and you have some scripts or something around those lines that YAML is effectively referring to. It's a provisioning scripts, in other words. So we've created in our same CloudFormation template that all the rest of the fulfillment lambdas and all that stuff gets deployed in. We actually create a provisioner lambda. This provisioner lambda has a whole bunch of functions defined in it that can call the AWS SDK and define some infrastructure. And we then, into that, too much hair, pass a Lex definition file. This is essentially a JSON format of everything that we would want to define about Nibby. It's really easy to go into the console and just set this up, and we just sort of transfer that back into a file that we can version control. And once we deploy the Lex definition together with the provisioner lambda reads the file, hits the APIs, creates the Lex bot, but it's all along with the CloudFormation. So we then can use, for example, the shared environment name of the branch, or we can delete it all at once, which is really nice if you've got 20 branches and someone's complaining about that $10 a month it's costing or something. So I'm going to head over to Shilpa now, who's going to talk more about how we make sure that we're comfortable with going to production with, and some other things, I think.
Thanks, Hailey. So what we saw right now, till now, was pre-built AI is great until it's not. So sometimes we actually receive a lot of unexpected results from the model. For example, in our problem domain, claims and hospital can have overlapping utterances. To a human, going to hospital and hospital claims are two different things, but not so much to Nibby. So this requires thorough end-to-end testing and to ensure that we invoke the right intent. So how do we do this? So before we get into that, so this is the existing chat flows that we support currently in Nibby. I know it's clearly not visible, but just to give you the complexity of what we have today. We have approximately 20 intents and some of them having multiple slots, so that involves some complex decision making based on the slot values. So when we actually extend and add new intents, how do we actually ensure that we're not breaking existing workflows? So we faced this problem when currently we were supporting only Nibby for domestic customers, and we wanted to expand it across other lines of business, like international customers, for example. So how do we make sure that we're not breaking existing workflows? That's the main problem that we have. So, and the answer is conversational regression tests. Okay, so this helped us solve this problem a bit. So what we actually did was this is a good example of how an end user would interact with Nibby. So we were simulating these by describing them in YAML files. And we were actually looking for an off-the-shelf library which would help us actually test the intents end-to-end. But since Lex is fairly new, we had to build our own package which would help us do this and give us more confidence, and that we were not breaking the builds and existing intents. So we just used JS YAML parser, which would then parse these tests and run them on the build pipeline. So what this helped us was, the positive things that we gained from this was it gave us a lot of confidence, and also automated testing of all the complex workflows that we have. So if you see, this is a good example of a failed regression test. So, so the expected message, the second one, is what we are expecting in a happy scenario where the customer has a happy, the customer is actually wanting to talk to an agent, and that's the message we receive from Lex. But actually, what is returned from Lex is a message that we show when there is an exception, and then the customer gets handed over to an agent. So there are the two different scenarios. So this is not what we were expecting, and hooking these tests in our build pipeline actually makes the build go red, and we can actually catch these mistakes early on. So, so that's that about development of Nibby and extending it across other parts of the business, and other parts of business, and adding new intents and new workflows. So what's next? What does the future of Nibby look like? Oops. So we are continuing to grow Nibby by adding new intents to it, extending it to other parts of the business, also having some, we're looking at having voice interfaces with like Alexa and Echo. And we're also looking at having fully authenticated transactions through Nibby. For example, a customer can just go to Nibby and then say, I want to update my phone number, I want to update my email address, and Nibby would do that for you after authentication. So we're also looking at having a 24/7 Nibby, which would basically not restrict Nibby as it is currently working only within the call center operation hours. But this would actually help us make Nibby global and cater to a global audience as well. So we are also looking to have voice-based bots in the phone system. So helping Nibby resolve some of the simple queries, or helping customers self-serve through the phone system, and also helping call center actually handle more complex queries. So thanks for listening to our talk. If you have any questions, you can catch us outside, or probably catch us on Twitter.
Yep, probably after, I think.
Yeah.
Better, because I think we're running. Workspace? What?
Feel free to raise questions.
Oh yeah, if you've got any questions,
Yeah.
happy to talk in like the open spaces, things
We're
like that.
actually quite early, so.
We've got 5 minutes. If anyone has any questions
Yeah.
immediately. I don't, unless that's not possible. That's good. If not, oh, Sam.
So Jemimah, you talked about instead of using conversation, having options, like being able to pick McDonald's or
Yeah,
KFC.
I cannot
Is that something that you're looking to use in Nibby, or is that
It is-
still going down the conversation?
Yeah, it's something that we've been investigating. It's not. I don't think it's.
No, we have
not
a
yet.
working POC, but it's not yet.
Yeah, it's not
it's
live.
not in
But there's certainly things that we've noticed that it just would speed it up for customers. Like if they don't know our internal language, we know what is easy for us. You know, like international worker, international student, or Australian resident. No one has to guess. We just put it there, and yeah, they can pick it. Yeah, but yes, it's not active yet.
We've got a question up the back. And up the front. I think people like me running.
Listen, do you have any sort of detection that works out whether people are going in loops? Just give you an example. The other day I was talking to the Commonwealth Bank chatbot, whatever they call it, but it kept I wanted to change a company mailing address. It kept telling me I could do it online, but it kept missing the fact that it was a company mailing address, and you can't do that online. And I kept cycling back to the same thing that kept insisting that it could do it. And that's the thing that got most frustrating, is that it just round and round and round ended up in the same spot.
Yeah, we have some fail-safes for that. So if it's something that I think there's a couple of times, if Nibby is repeating itself, we just hand over to an agent. Because there are some things where, I think we saw early on, it was just this vicious loop, and customers were really persistent, and I felt so sorry for them. But yes, so we have put a stop to that.
Yeah, I think it's like two attempts.
I think it's
now.
2 attempts. Yeah.
We're down the front now.
A very good talk. 2 short questions. How did you come about with the name Nibby?
There was an internal competition.
At least it's not
I think
like
there were
chatty
votes.
McChatface.
Yeah.
One more.
I'm not going to tell you what the working prototype name was.
Have you considered using something like Whobot as a way to develop it so that it could be deployed easily? Rather than having like small parts all together glued, rather than that, having a framework where you could write the whole thing and then try to deploy it. For example, GitHub has a framework for chatbots called Whobot, H-U-B-O-T. Have you actually explored in that area?
I'm not 100% sure if we explored potential the frameworks. So I guess the main benefit of like why we went with Lex is that A, it was available and we didn't have to run anything. So I don't know with this framework in particular, it could be something worth looking at. But if we have to start running infrastructure, then we get very less interested in it immediately. So is that like a machine learning AI type framework? Or
It's just a framework where you can build bot on top of it, but then those could talk to anything at the back end, like Amazon or any other
so
things.
it's like a generic kind of
It's a very generic bot framework.
I did not know that was a thing. That's cool.
Yeah, that's good, yeah.
We
Okay,
should have to look
thanks.
into that. One more or?
One more. If you're quick. Yeah.
Really quick, look, thanks so much for giving us a bit more insight into Nibby and the work that's gone on behind it. I'm doing a PhD at the moment that just focuses around AI and healthcare. So we know there's a lot of conversational platforms that are evolving really quickly. I'm just wondering how you cater for some of the logging and discovery after the fact. So how are you going to be able to support people being able to inquire into what the outcome is and how long you're going to be able to try and keep your logs for?
So how long we keep our logs for? Because, well, we would probably similar regulatory things. Like we keep our logs for like 7 years or something, I think. I think these are But I don't. Yeah. Yeah. Kurt can answer.
From memory, I believe it's about a year. We ship all our logs to Sumo Logic, which is equivalent to Splunk or Elasticsearch. We've got a lot of this infrastructure set up across the board that we utilize. Anyway, we'll wrap it up there.
Thank you, everyone.
Thank you.
Thank you very much.
Thank you. Thanks to Shilpa and Hailey and Jemimah.